the foundation typically refers to the process of starting construction on the foundation of a structure, such as a building or bridge. This phase involves laying the groundwork to ensure the stability, durability, and load-bearing capacity of the structure. Here's a step-by-step guide. 1. Site preparation, clearing the site. Remove debris, vegetation, or any existing structures in the area designated for the foundation. Leveling and grading. Level the ground and ensure proper grading for drainage and stability. Surveying. Use surveying equipment to mark the foundation layout accurately. Fastening steel, concrete, and bridge piers involves combining structural elements to create a stable and durable foundation for a bridge. The process integrates steel reinforcement, concrete, and piers to handle loads effectively. Here's a step-by-step guide. 1. Preparation A. Site inspection. Confirm the soil and foundation preparation is complete. Check alignment and markings for the pier locations. B. Materials and equipment. Steel, reinforcement bars, rebars, tie wires, bolts, or anchors. Concrete. High-strength mix suitable for bridge construction. Equipment, cranes, formwork, vibrators, drills, and welding machines. C. Safety measures. Ensure workers use personal protective equipment, PPE. Implement proper safety protocols for handling heavy machinery and materials. 2. Steel reinforcement installation A. Placing rebars. Position steel reinforcement bars according to the design specifications. Securely tie rebars together using tie wire or welding at junctions. Ensure adequate spacing between rebars to allow concrete to flow evenly. B. Anchoring steel. Drill anchor holes in the foundation or base if specified. Fasten steel bars or plates into the foundation using bolts or epoxy anchors. Use templates to maintain precise alignment. C. Structural checks. Inspect the steel framework for strength and alignment. Ensure reinforcements extend into the pier shaft for proper bonding. 3. Pouring concrete A. Formwork setup. Assemble formwork around the steel reinforcement for the pier shaft. Ensure the formwork is stable and leak-proof to maintain shape during pouring. B. Concrete placement. Use pumps or buckets to pour concrete into the formwork. Compact the concrete using vibrators to eliminate air pockets and ensure uniform density. C. Curing. Allow the concrete to cure for the recommended duration, typically 7 to 28 days, to achieve desired strength. Keep the concrete moist during curing to prevent cracking. 4. Erecting bridge piers A. Pier shaft installation. For precast piers, lift and place the precast pier sections using cranes. Align the sections properly and fasten them with steel connectors or bolts. For cast-in-place piers, build the pier shaft using the reinforced concrete process. B. Connection with steel components. Install anchor bolts, plates, or dowels at the pier head to connect with the superstructure or additional steel members. Weld or bolt steel elements securely to the pier for load transfer. 5. Final fastening and inspection A. Structural fastening. Tighten all bolts, anchors, and connections to design specifications. Add grout or epoxy to fill any gaps between steel and concrete interfaces for additional strength. B. Quality checks. Inspect for alignment, structural integrity, and compliance with design specifications. Conduct non-destructive testing, UV, ultrasonic testing, on critical connections. C. Safety and load testing. Perform load tests on piers and connections to ensure they can handle expected loads. Slab is an integral part of bridge construction, providing a smooth transition between the bridge deck and the surrounding road or pavement. It serves to prevent differential settlement between the bridge and the roadway, ensuring a seamless connection and maintaining safety for vehicles. Here's a step-by-step guide on how to construct an approach slab. 1. Site preparation A. Excavation and grading. Clear the area, remove debris, vegetation, and any obstacles around the bridge approach area. Grade the subgrade. Level the ground to create a stable base for the approach slab. Ensure the subgrade is compacted to avoid future settlement. B. Ensure drainage. Install drainage. Make sure proper drainage systems, e.g., culverts, ditches, or pipes, are in place to prevent water accumulation beneath the slab. Slope considerations. Ensure the approach slab slopes adequately towards drainage systems to avoid water pooling. 2. Design and layout A. Alignment. Survey the site. Use surveying tools to align the approach slab with the existing road surface. Check for elevation. Confirm that the slab's elevation is level or slightly sloped to match the road and bridge deck. Ensuring a smooth transition. B. Formwork. Set forms. Install temporary wooden or metal forms around the edges of the approach slab to shape and hold the concrete during pouring. Reinforcement placement. Ensure the reinforcement bars, rebar, are placed within the forms according to the design. The rebar will provide tensile strength to the slab. 3. Reinforcement installation. A. Steel reinforcement. Position rebars. Place horizontal and vertical reinforcement bars inside the formwork based on the design specifications. Overlap and tie. Ensure that rebars overlap at the ends and are securely tied together with wire to form a continuous reinforcement network. Maintain spacing. Ensure the correct spacing of the rebars to ensure effective bonding with the concrete. 4. Concrete pouring. A. Mix and pour concrete. Concrete mix. Prepare high-strength concrete, ensuring that it is adequately mixed to achieve the desired consistency and strength. Pouring process. Pour the concrete into the formwork starting from one end and working your way along the slab, ensuring the slab fills evenly. Compaction. Use vibrators to compact the concrete and remove air pockets. This ensures uniformity and strength in the slab. B. Leveling. Screed the concrete. Use a screed to level and smooth the surface of the concrete, ensuring it's at the correct elevation and smooth for a proper road transition. 5. Curing and finishing. A. Curing the concrete. Curing time. Allow the concrete to cure for at least 7 to 28 days depending on the mix design to achieve optimal strength. Moisture retention. Keep the concrete surface moist during curing by covering it with wet burlap or plastic sheeting to prevent cracking. B. Surface finishing. Smoothing. After initial curing, finish the surface by using a trowel or power float to achieve a smooth, level finish. Texturing. If required, apply a surface texture or broom finish to ensure good traction for vehicles. 6. Joint installation. A. Expansion joints. Install joints. Add expansion joints where the approach slab meets the bridge deck and where the slab meets the road surface. These joints allow for movement due to temperature fluctuations and prevent cracking. Sealant application. Apply appropriate sealants in joints to prevent water infiltration and ensure durability. 7. Final inspection and site cleanup. A. Quality check. Inspection. Inspect the approach slab for alignment, cracks, smoothness, and proper joint installation. Load testing. In some cases, conduct load testing to verify that the approach slab can withstand traffic loads. B. Clean up. Remove forms. Once the concrete has fully set, remove the formwork around the slab. Restore site. Clean the surrounding area and restore landscaping or road features impacted during construction. 8. Opening to traffic. Traffic control. Allow time for the concrete to cure completely before opening the approach slab to traffic. Final signage. Install road signs indicating the presence of the new approach or any changes to the road. Thank you for watching.